love you in the every universe. Yes, I'm talking about the Doctor Strange, the multiverse of madness. I'm a great fan of Marvel, so that's why I decided to make one Doctor Strange filter using the OpenCv Python and the Mediapipe. So without any further ado, so let's get started. So in order to build this project, first you need to install some library. So the library name is OpenCv and second one is called the Mediapipe. And also you need to install Python on your local machine. So if you're trying to install the library, so just open your command prompt and type here pip install, and the library name is called the OpenCv Python. So let's say OpenCv Python. And also you need to install another library that's called Mediapipe. And second one, you need the country package of the OpenCv. Sometimes it's needed or sometimes not. So it's better you can actually install this library. So let's say OpenCv country Python. Make sure that just you install those library and you can actually build this project easily. So now let's try to build it out. Well, so now let's create one empty Python file. Let's say main.py. So first we're going to create one camera, and after creating the camera, we are actually detecting the landmark of our hand. So let's import here the cv2. And now we are going to actually initialize here one video capture object. Then we are going to actually create one infinite loop, and after that we are going to show the frame. So let's say video equal to cv2 dot video capture, and inside it we put here 0. Why 0? Basically we are actually using a default webcam that is already attached on our laptop. So now we are going to create one infinite loop. So let's say while true, and then we are going to actually read the frame using this video capture object. So let's say video dot read, and this will actually give here two value. First one is nothing but the boolean value, that's your camera is available or not, and second one is the video, the where you are actually trying to store it. So I'm going to store it inside the img, that's an image. Then after that I'm going to show it here. So let's say cv2 dot imshow. So this imshow actually take two parameter. First one is the window name, so let's give here one window name, let's call image, and also your material. So our material is nothing but our image. Then you need to keep here one keyboard binding functions. So which one actually waiting for your keyboard? So let's say keyboard here to cv2.writeKey. So inside that we actually give here one. So it actually waiting for the keyboard. When you press the keyboard, something from the keyboard, so it will actually automatically break this infinite loop. So I am going to prepare it for q. So let's say if k equal to ord, that's mean ord is nothing but taking the input from the keyboard, and after that we are going to break the loop. Well, then what I'm gonna do, we are going to actually release the video that we actually taken using our video capture objects. So let's say video dot release, and finally you're going to destroy all the windows. So let's say cv2 dot destroy all windows. Well, so now what I'm gonna do, I am going to run the code. Just you can go on the terminal and create new terminal, or you can also run the code from here. So let's say python main.py. Well, now you can see here it open my webcam. You can see here. Well, so now what we're gonna do, you're going to detect the hand, that's mean our hand landmark, using the Mediapipe. So let's see how can you do that. Okay, so for that what I'm gonna do, I'm going to actually import here the Mediapipe, okay, as MP. So now we need to create the solution of this Mediapipe. So because we are going to actually detect the hand, we are going to actually using the solution for the hands. So let's say mp dot solutions. This solution we are actually detecting the hands. So let's say hands. Okay. Now you are going to store it inside one variable that's called mp hands. Well, so we actually store it. Now what we're going to do, we are going to actually create one instance of these mp hands. So let's say mp hands, this mp hands dot hands. Okay, this is not, this should be capital, this should be capital hands. We just create one object for these hands, and you're going to store it inside our variables. So inside this hand, it have the coordinate value of the hand landmark. Then if you're trying to draw it, that's when you're going to connect the landmark, you can actually using the draw utils from the mp solution. So for that you can use mp dot solutions dot draw utils. Okay, that's when you can actually draw the utils. So let's say drawing utils. this one. Now let's store into one variable that's called mp draw. Well, cool. So now what I'm gonna do, first you are going to flip this image, because OpenCv actually flipping the whole part, it's like one mirror. So first what are you gonna do, we are going to actually flip this full frame, so that right will be right and left will be left, like that. So let's say cb2.flip. We're going to flip that. We are going to flip the image and also give here one value, let's say true. That's been 1. Then we need to actually convert this frame into RGB, because this MP solution hands taking the input as RGB image, not BGR. But OpenCV did the image in a BGR format. So for that, what I'm going to do, we are going to actually convert this into RGB. So let's say cb2.cbt color. So this color, you're going to put here our image and our color code. So let's say cb2.color BGR2, which one? BGR2 RGB. So BGR2 RGB. Well, now you're going to store it inside one variable. So let's say this is our RGB image. Cool. So now what we're going to do, we are going to actually process this using our hands, these hands, because inside this hand we have all the coordinate of the landmark. So let's say we are going to process that. So let's say process. We are going to process here the hands. Which one? Okay, hand, not hand, actually RGB image. Well, this, and we get some value here. So let's say result. So basically this is the image for a hand landmark. If you see the landmark, you can see here it have 21 value, start from 0 to 20. So this is the all point of the landmark. We are actually going to collect them. Well, so now if I'm trying to print the result here, so let's say print the result, and let's see what you actually get here. So go here and actually type here Python main.py, and it will open the webcam and it will actually process them. Okay, we got some error here. cb2 has no attribute called flip. Okay, this should be not flip, that should be flip. Okay, now let's run the code here again. Well, you can see here it is nothing but one class. See, we got one here Mediapipe Python solution base solution output. Just we got the output here. Now we need to actually draw the landmark of our hand. Well, so now let's see how can you actually draw that. So if the result is available, so let's say if result is available, that's if result dot multi hand landmark. Let's say multi hand landmarks. Okay, there should be landmarks. That's mean if we have the result inside our frame, so we are going to actually creating one loop and iterate to all the coordinate value from the result. So let's say for hand in our result dot multi hand landmarks. Okay, just copy this, and it will actually give here two value. One is the ID. That's mean this. If I go to this picture again, you can see it actually give here the ID and the landmark. That's mean the position of the hand. So for that we are going to actually enumerate the thing. So let's say for ID and also the landmark in enumerate. Okay, just we are going to enumerate all the things from here from our hand landmark. That's mean our this hand landmark, hand dot landmark. Cool. So now what we're going to do here, we are going to actually, we got the landmark and also the ID here. So now you can also draw it. That's when you can also draw our solution, and we can also show the circle here. So if I am trying to actually show here, let's say if I am trying to show here the circle, the coordinate of the circle. So what we're going to do, we need also the width and the height of the channel of our images. So let's say height, width on the channel of our images. Then we can actually get the coordinate of that. Then after getting the coordinate, we can actually creating one circle. But if I am trying to actually show the hand landmark, so we can actually using this MP draw, right? That's mean MP draw, this one. So let's use this one, MP draw dot draw, what do you call, draw landmarks. So let's say landmarks. So this draw landmarks actually taking some value First one is nothing but our image. Second one our the hands. Another one is called the connection. So let's say mp hands dot, that's mean this np hands dot hand connections. Well, so now let's save it and run the code here that you can got any error or not. So let's run it now. Well, you can see here detect the hand landmark correctly. Well, you can see. So you can see here on some circle. We can also get the position of the circle here. See how cool it is. So if I am trying to actually just print this circle, we can also do that. So how can I do that actually? See, just actually use here the Q from the keyboard. Yep, gone. Well, so now if I'm trying to just show the circle, so what I'm gonna do, we just need to actually get the coordinate value of that. So let's say coordinate of the x and also the coordinate of the y equal to integer of lm, that's mean lm dot x into y, and also the integer of the y coordinate dot y into the height. Now we can actually show the circle. So let's say cb2 dot circle. We can just simply show it the circle inside our image. So you need to give here the coordinate of the x. So let's say coordinate of the x and coordinate of the y. Coordinate of the y. And also what I need to do, we need to give here the radius. So let's give here 6. So let's give here one color. Let's give here the red color. Let's say 50, 50 to 55. And also give here the thickness. So let's give here -1 so that it looks fill. And I am not trying to actually right now drawing the landmark here. Just go to the terminal. It's better use the terminal so that we can actually see the value also. So let's say main.py. It's better we can also print this coordinate value also. So let's say try to print here the coordinate of the x and also the coordinate of the value of the y. So let's try to print it out. Coordinate of the y here. Cool. So now let's run the code here. All you can see here just the value, that's in the circle is appear on here, and you can see here some value. Well, it's nothing but coordinate of each point, right? So you can see here some coordinate value. This is nothing but the coordinate value of the each point. That's really cool. So now our work is slightly done here. So now what we're going to do, we are going to create the lines that you see in the doctoral streams. That's in our demo video. You actually see that how the lines should be created. So how can I actually draw the lines here? So this our landmark. Just we are going to actually connect all the tip value to the this thumb value. That's mean if I run the code again and I'm trying to show it again. So let's also uncomment this and also try to run the code here. Let's say python main.py. So what are you actually going to do here first? See, we are going to actually connect this point, this point, this point, and this point to this point. Well, and also this plumb point to the all 4 point. That's mean just going to connect them. So for that, what do you need to do? We need to just make it unique, and after that you are going to just store all the value, all this point tip value, and you're going to just connect it from here. Okay, so let's see how can you actually do that. So for that we need to store this 8, 12, 16 and the 20 and the 4. Just we need the 4 and 5 value and also this width. Okay, just you are going to take that and also just you're going to connect this one and also this one and this one, and finally you're going to connect this plumb to all, right? So for that what I'm going to do, we need to just extract the position data of the each coordinate. So for that what I'm going to do, we're going to define one function that's called def position data, which one taking one list. This list is nothing but our coordinate. Okay, so for that we need to also create one list. For that, if you see here, just see here, this is the coordinate of the x and the coordinate of the y. Just we need as a list of the landmark. So it will actually take one list of the landmark, and after taking the list of the landmark we get the ID and also the landmark positions. Then what I'm gonna do, we are going to actually create one global variable for width and a thumb tip index MCP. That's mean if I go here, we just need this thumb, that's mean 4 number thumb tip, and number 8, that's for index finger tip, and this is a 12, this is nothing but our what is called this middle finger tip, and also this one is nothing but called the ring finger tip, this one tip, and also this pinky tip. Okay, so you can see here we actually initialize here all the variable here. You can see here middle tip, ring tip, pinky tip, and the index tip, and the index MCB and the thumb tip. But we don't need this right now here, the 5 and the 9. So 5 is nothing but the index finger MCP and also the middle finger MCP. Later on we need it when you actually calculate the distance of the plum. That's when you actually calculate the ratio of the plum when you're actually trying to overlay the images of the Dr. Strange's magical circle sheet like that. So now we are just focusing on just creating the lines. After creating the lines, just we can overlay the picture and we can actually animate them. Now what we're gonna do, we are going to take the width one, that's in our plum value one. So for that, width equal to lm list, this inside list, position number 0. If I y0, if I go here again, you can see this is nothing but called as 0. So 0 to 1, okay, 0 to 0 and 0 to 1. Then we need the thumb tip. So thumb is nothing but our 4. That's mean this 4. You can see here thumb is 4, and this is the number 8. That is index finger tip, and you can see here index MCP number 5. Then number 8, that is for index tip number 8. Then the 9. Then number 12. This is nothing but the middle tip, and another one is called the ring tip and the pinky tip. And you can see here 16, 1, 21, 20, 0. That's in 20, 0 to 21. It will actually give here the landmark of the position of the each value. Now we need to create one list. That's we need to create one list which will actually store the ID and also the we will actually store the coordinate of the x and the y. Okay. So for that we need to actually create an empty list. Let's say lm list, and inside this lm list we are going to actually append this coordinate x and the coordinate y value. So let's see how can you do that. So let's say lm list dot append. Just you're going to append here the coordinate of the x value and the coordinate of the y value. Okay, coordinate of the y value. Now we can actually draw the landmark using this position data, right? So for that we need to also call this position data here. So let's call it right now. So we don't need the mp draw hand landmarks. If you can actually take here. Now we need to actually draw the lines. So how can I draw the lines? We just draw the lines. Just connect this one to this one, this one to this one, and this one to this one, and this one to this one. Really simple. So for that, what do you do? We need to define one function that's called a draw line. It will take one points and the points too. That's mean the coordinate, and you can give here the size of your lines. So it will actually we are just creating one lines using this point. So now what we're gonna do? We are just going to actually call this function inside here after the position data, right? Well, so now what we're gonna do? We are going to actually connect this width to the all point and also the thumb to the all point. So for that, we are going to just draw the line here. So first, we are going to connect the width to the thumb number tip, and then we are going to actually connect the width to the index tip and the middle tip and the ring tip and also the pinky tip. Now we are going to actually connect the thumb to the all of the index tip, middle tip, ring tip, and the pinky tip. So for that, we are going to thumb tip to the index tip, thumb tip to the middle tip, and thumb tip to the ring tip, and also after that, we are going to actually we are going to thumb to the pinky tip. So it will actually connect all the point of that. So now if I save it and try to go on the terminal and actually try to run the code here. So let's say python main.py. Then you can see here we can actually it actually draw one lines. Okay, just we got one error. Position data missing one list. Okay, it will taking one list as argument. So for that, what I'm gonna do? We just going to pass here this lm list. Okay, we can also comment out this line because we don't need to actually draw the line here. That's mean draw the landmark here because we are actually drawing the lines here. So for that, so it will open the webcam and you can see here it draw the lines. See how cool is it? Yep. You can also do some customization. You can actually add here the white line also. See how it looks like. Cool. So let's add here one white line in the middle of that so that it looks cool. So now let's add here one white line. So let's say CB to the line. and inside there just we could give here one just simple size to be so that it looks cool. Just point and give here the color code. So if I run the code here again and see the output, then you can see here one important thing that is really looks cool, like you see earlier, and you can see here that's really cool, white and the red, cool, like Dr. Strange. Well, fine. So now what we're gonna do, so when we are trying to actually make it full, that's mean after plum, if the ratio is bigger, then we are going to actually overlay the picture of the medical circle of the Dr. Strange, right? So for that, what you need to do, you need to just calculate the ratio of the finger from there to there. That's, you need to just calculate the distance from them, and after that you're going to actually calculate the diameter, and after calculating the diameter, what you're going to do, you're going to just overlay the picture, then you're going to make it animate later on. Okay, see, so when it will actually open like this way, then you're going to actually overlay the picture. So for that, what you need to do, you need to also calculate the ratio of that. So you need to also calculate the distance of that, this point to this point. So if you're coming from the mathematics background, or if you actually learn something in your beginner age, that's mean the primary or the secondary, you know how to calculate the distance of each point. So there should be one rule to actually calculate the distance from each point. So this is nothing but called x2 minus x1 whole square plus y2 minus y1 whole square and root over. To actually using this formula, we can actually calculate the distance from the each point. And after calculating each point, we can actually show that we can draw the lines or not. So now let's define one function that's called the calculate the distance. It will take one points and the points 2. That's been point 2 and the point 2. That's nothing but called x1 and the x2, or like that x and y. So we are going to actually taking the x1 and the y1 and x2 and the y2 from the each point. And after that, we are going to actually using the formula that we see earlier. That's when we actually discuss about that. X2 minus x1 whole square plus y2 minus yn whole square into root over. That's mean 1 by 2 equal to 0.5, and 0.5 means this is one root. So we just calculate the length of the each data point, and after calculating the distance of each data point, then what are going to do? We are going to actually taking the distance from this plum to this middle point. After that, we are going to calculate this ratio, this whole ratio, and when you actually divide this plum to the distance to the plum, we can actually get the ratio of the each hand. Okay. So now what we're going to do here, we are going to calculate the distance from the wrist, this means this wrist to this fingertip. That's this number 5. Sorry, not finger of the tip. We just calculate the index finger MCP. That's mean this one. We are going to just calculate this point because this here one have joined. So we're going to calculate this point to this point. Then we can actually get the plum distance here. This is nothing but our plum distance. And based on the plum distance, we are going to actually divide it, the whole distance, by the plum. Then we can actually get the ratio, right? So for that, what we're going to do, we are going to actually first calculate the distance of the wrist to the index MCP. That's mean this one, index finger MCP, 5 number 1. So now we got the plum distance, and after that we are going to calculate the whole distance from the index tip to the pinky tip. That's mean index tip mean this index tip to the pinky tip. Just we're going to calculate the whole distance from the each point. Now we got the plum distance, and also the finger distance. Now if I actually divide this distance to the plum distance, we actually get the ratio of the whole hand. So now let's try to print here the ratio. So let's say ratio. Okay, so we can also draw the lines just a while, and if I go into terminal and try to run the code here, so let's say python main.py, and if I run the code, just see in the terminal one thing. Well, you can see here detect a landmark, and you can see here some value. I think it's better we can also comment out this MP solution one. So now let's run the code here. Let's say python main.py. Well, you can see here right now, you can see here value is 1.5. If I actually decrease it, you can see here 1.0. So when you are trying to make it full, that's mean if it is greater than 1.5, that's mean 1.3 like that. So we are going to actually make it invisible, and after that, instead of using this line, we are actually using the picture of the draw circle. That's mean the magic circle, right? So you can see here right now for this hand, you can see 1.3. If I actually make it full, you can see here 1.3 something. Okay, you can see 1.3 something like that. Cool. So 1.4 now. So if I am trying to make it full, then we can actually invisible. That's when you're actually replacing this hand line to the picture, right? So now what I'm gonna do, if I am trying to actually, if we show that if this value is less than 0.3, 0.3 means this is no landmark. That's in no landmark is actually created. So for that, what I'm gonna do, we are going to actually create one condition. So if the ratio is, if the ratio is greater than 0.5, okay, 0.5, and also the greater than 1.3, okay, 1.3, then we are going to draw the lines. Otherwise, we are going to actually overlay the picture, right? So let's see and test it out that is really working here fine or not. So let's say Python main.py. See, so when you actually making it like that, it will draw the lines, but when you make it full, and it will gone. Now, instead of drawing a line now, we are going to actually overlay the picture, right? Now it looks cool. Vector strings. But it's not actually working sometime because it just depend on the camera, and I'm just inside my home and at night. Just I'm recording the video. Okay, so now what we're going to do, you're going to actually overlay the picture instead of using drawing the line. Okay, so now let's see how can you do that. So now what we're going to do, inside our folder, this magic circle, you can see here we have the images, circle 1, circle 2, and the circle the CCW and CW. So now what we're going to do, we are going to actually using this circle, and we are going to just overlay these, extract this whole overlay, and after that you're going to actually make it transparent. Okay, so now let's see how can you actually do that. Okay, so for that, what I'm going to do here, we are going to first load the images here. So let's say image 1, this is read from this CCW, and another one is the image 2. So now we need to actually make it transparent, right? So now what we're going to do, we are going to define one function here. So let's define one function that's called def transparent, so which one take one target image, and the x coordinate and the y coordinate, you can also give here the size. So if the size is not none, that's mean you need to also resize the images, right? So for that, what you're going to do, you're going to resize these images based on our target images. Then we are going to take one copy of our images so that we can actually use it later on. So now we are going to actually extract the alpha marks of the RGB images. So we just actually extract the alpha channel from our RGB images, but in this case it is not RGB, it's actually BGR format because OpenCv read the image in a BGR format. So first we are going to actually extract the alpha channel of our RGB images, and or you can say BGR images, then you're going to convert it into the BGR or RGB. So for that, what you're going to do, you are going to actually overlay the color. That's mean you're going to merge the BGR. Just we are going to actually take the alpha channel of the images, that's our target images, then you're going to create one overlay color. Okay, then what you're going to do, you're going to create one mask. So this mask is nothing but for a simple filter to actually remove the noise, that's it is noise from your magic circles. Then what you're going to do, we are going to actually taking the shape of our overlay color, that's in our overlay shape. Then using this shape, what I'm going to do, we are going to actually create one RY. That's we are going to actually cut the frame. If I go here, if I go the picture, you can see here it will take the picture like that, and it actually remove the alpha channel from the each images, and it will actually taking the RY of the whole images. Then based on the new frame, that's mean this new frame, it will take the RY, and after that, what I'm going to do, we are going to make up the logo from the logo image. That's mean you're actually creating one bitwise AND operator, just creating one marks, and after creating marks for the image number 2, that's mean image 1 and the image number 2, then what I'm going to do, we are going to actually replace the updated image, that's mean the original image, to the RY images. That's mean these images. Just we are going to actually using this image 1 and the image 2 inside our new frame. That's mean our actual frame, means our the frame that is this images. That's how it actually detected. We are going to just replace this background into this whole background. Okay, then after that you're going to actually return the new frame. Okay, so that's how you actually copy the whole images, After images, you're going to replace this background. That means you're actually making what some kind of transparent. Okay, so now our transparent work is done. So it's time to actually show the images, and after showing the images, what are you going to do? You're going to actually rotate it, right? So now what are you going to do here? If the ratio is greater than 1.3, then you are going to actually make the image should be transparent. You are going to show the shield. That's mean our magic circle. So if this ratio is greater than 1.3, then what are you going to do? You are going to first calculate the center of our index MCP. That's our medial MCP. Because this is the length one, notice this medical shift. If I go to the hand landmarks one, we just calculate the center, that's mean this center of this shield. So center of the shield is nothing but our 9 here, okay? This 9, middle finger MCP. So just we are going to actually use this sheet, that's mean this is the center, and based on the center, you are going to actually draw the sheet. That's our magic circle, okay? Because this is the center, so we need to just calculate the center of the X and the center of the Y. So for that, we are going to calculate them, the center of the X of the middle MCP and the center of the Y of the middle MCP. So after actually calculating the middle sheet, just we are going to actually keep here the one sheet size. That's mean the magic circle size. And after actually giving this, we are going to actually calculate the diameter of our sheet to our plumb. That's mean we actually already calculated our plumb here. It's my plumb distance. And based on that, we are going to just show this like that. Okay, like that. So this is our center. So this sheet actually start from the center and go to the plumb. So this is our diameter. Okay, and after determining the diameter, so what are we going to do? We are going to actually calculate the top corner and the left corner. That's in top left corner, so that it's not actually go out of this hand. Okay, so now what we're going to do here, we are going to actually keep the short the inside the frame. That's when you're going to actually keep the shield inside our frame, so that it's not actually going out of the frame. So for that, you're actually taking the shape of our images, that's mean height, weight, and the channels. Then if it is actually less than 0, then you're going to make it 0. And if it is greater than 0, so just you're going to make it height. And for the Y, it is simple like that. And also you can actually add here the diameter. If it is actually greater than diameter, just you're going to actually make it minus. And after that, it is actually based on the height, so just you're going to actually minus the height to the y-axis. So this is nothing but for the increment the target angle of our sheet, okay, so that it's not actually go out of the hand landmark. Then what we're going to do here, we are going to actually trying to rotate it. Okay, so for that you're going to actually get the sheet size, that's our magic circle size. So this is nothing but a diameter and the diameter. And our angle is actually start from the 2.0, and we are going to just give here one simple angle degree. And after that, if the degree is 360 degree, then we can actually rotate it again. So for that, we are just going here to get the value from the degree. Then what we're going to do, we are going to actually get the rotation matrix of the shield. So for that, we're actually using here the get rotation 2D. So for that, we need to also calculate the center of the rotation, so that it actually rotate based on the center. Okay, so for that, you're actually using the cb2.get rotation matrix 2D. It will actually tape here on the center. That's in how you're trying to actually rotate them, and also the degree of the round degree. And you can see here for the M2, it actually trying to rotate them in each degree. Then finally, we are going to apply the rotation matrix of our images. Just you can actually declare it, this M1 and the M2. Then finally, we're going to apply it inside our images, so that our image looks like animated. Then we are going to check that if the diameter exists, we can use the sheet. Otherwise, we don't actually using the sheet. So you have the two sheet. One is image 1 and the image 2. You're actually using this inside our sheet. So now we need to also define the degree here, right? So let's say degree. We need to also define it here. So let's say degree equal to 0. Cool. So now we need time to actually check it out. That's our code is actually working here fine or not. So just actually save it. And if I'm trying to go to the terminal and type here, also close it now. And if I type here the python main.py. So let's say python main.py and test it out. That is really working here fine or not. See, now you can see here our sheet is actually coming up, and you can see it rotating. Well, See how it looks. Well, fine. It's not actually working clearly because my camera resolution is not good and it's at night too, so that's why. And my lighting, my room condition lighting is not so good, so that's why it's something give me error. You can also use some another images, and you can also make the frame should be big. So we can also check this out, how can I actually make this frame should be big. So let's also do that. So let's say video dot set, and it have one value that's called 3, and it will take here the width. Let's say give here 1000, and also the set the height, so let's say 4, so this should be the 780. And we can also use another picture from here, so let's use the picture of 1 and the 2. We can also use this, let's say 1, and another one is called 2. You can also use that and go to the terminal, and I have already one terminal, so we can actually run the code from here. Just run the code and see the output, how it will look like. Cool. So this our window. Wow, boom, that's our medical sheet. See how I need actually go here, but how I actually make it full, and you can see here some value is actually appeared on the terminal, and you can see it greater than 1.3, then our sheet is appeared. Cool, fine. Okay, that's really fine. It's better you can actually use it the CCW, because this is really work like the real Dr. Strange. And I am also a great fan of the Marvel. I also watched the movie of the Marvel, and my favorite icon is obviously Tony Stark. Well, that's really looking cool. Fine. So this is all about the whole tutorial. Hope you'll enjoy the tutorial, and make sure to subscribe to my channel, and don't forget to hit the bell icon for never miss an update. And I'll be back with another tutorial. So till then, take care and bye bye.